Hey, hi folks. So today we'll be talking about Amazon Bedrock agents. We'll talk about what are the capabilities available in Amazon Bedrock agents, and then we'll talk a little bit about the knowledge bases capabilities, which is already there. Then we'll take a look at how can we use Lambda functions via action groups, attach them to a Bedrock agent, and then use that to basically do RAG from a data source other than Bedrock knowledge base. For example, maybe Astra. So let's take a look. First of all, what is Amazon Bedrock Agent? This is a specific service from Amazon where there is a low code approach to go ahead and create agents and then even attach tools to them. Right? They have different features available over here. You can create multiple agents and have them collaborate with each other. There is inbuilt capability over here to go ahead and perform RAG. And that is probably one of the biggest benefits of using Amazon Bedrock agents because you do not have to go ahead and build the entire RAG pipeline on your own. You can just go point and click, do ClickOps as is, connect your knowledge base to a bunch of pre-built data sources which are available for you out of the box, and your RAG pipeline is ready to go. But even though it is so easy to go out and do that, it comes at a price. You are constrained to the options which Amazon provides to you, as well as there is obviously the cost that comes with using this service. So let's take a look at what we'll be covering in this video today. Okay, so this is the starting state. Here we see the high level overview of what using Bedrock agent looks like. We have the user over here who's interacting with the Bedrock agent. Within the framework of this service, we have the orchestration engine, we have the capability to go out and version prompts, we have memory summarization for the back and forth that is happening between the user and the agent. There is memory summarization capability, which is available out of the box. You do not have to go and search for third-party models externally. You can directly go ahead and use Bedrock models directly and hook it up with your agent. There is no extra plumbing work that needs to be done where you go ahead and get an API key or an access key or configure the endpoint. That is not needed. You can just go ahead and request access for one of the models which is already available on Bedrock, like say either the Nova models, which is pre-built, or say maybe the Anthropic models. And you can just go ahead and click them, select them, and they're available for the agent to go ahead and use as their brain. Now, coming to the memory aspect of it, there are different knowledge bases, or rather, you can create multiple knowledge bases. You can have one knowledge base connected to one or more data sources. You can have your files, your proprietary private files uploaded to an S3 bucket, have that synced up with your knowledge base, and have that information show up in your knowledge base. So it's kind of convenient that way. You can also go ahead and have it hooked up with your Microsoft SharePoint, with your Atlassian Conference, wiki, so that all the information that you have constrained to your intranet, your company's intranet, that is available for the knowledge base to have. And then the agent, as a result of being hooked up with the knowledge base, is able to go ahead and connect to it, get the relevant information whenever needed to service the user's request. So there's that part. Now moving on to the right hand side, we have action groups. So whenever you want an agentic application to be built. You want your agents to be able to go ahead and perform some action in the real world, either to go ahead and make an observation or to go ahead and do something. Send an email or maybe go ahead and make an API call. Okay. So different types of actions that you want your agent to perform rather than just output some text or code. So that is where you would need your action groups configured via AWS Lambdas. And obviously there's guardrails over here. So now this is good. This is very convenient, but at the same time, it is constrained to only the AWS ecosystem. But what if your particular scenario demands that you go ahead and connect with something which exists outside of the AWS ecosystem. So we'll take a look at that. AWS has made it quite easy to go ahead and achieve that. So let's consider this target state. Let's assume that we have our Astra DB vector store already configured and we already have data in that. And then we want to go ahead and have Bedrock agent being used as our orchestration layer for the different agents, or maybe even it's a single agent over there. But that's what we want to go ahead and use for our agent framework. How do you go ahead and connect our Bedrock agent with something which resides outside of the AWS ecosystem? Well, it turns out it's quite easy. We can use serverless functions or AWS lambdas to go ahead and function as tools for the agents, where you just need to go ahead and say that, hey, this particular Lambda needs to go ahead and connect to this non-AWS service, some external service out there, which in this particular scenario is going to be an Astra DB. You just say that this Lambda connects over there, makes the API call, gets the information, and then performs the RAG pipeline. So this is what we are going to achieve. Now let's go ahead and take a look at how we will do this. You go step by step so it's easy to follow.
So next we'll go ahead and create a simple Bedrock agent. Here are the instructions for the agent. You are Batman, respond like he would to every question. Remember, you are the knight, because why not? We'll head over to our AWS console. You can go over here. I already see Amazon Bedrock listed in the recently visited card. But if you do not see that, you can go to the search bar, search for Bedrock, Amazon Bedrock, agents. So this is what the Amazon Bedrock agents page looks like. Over here, you go to the create agent button, give it any name that you want. The description part is optional. We do not need to check this enable multi-agent collaboration option because we are going to create a single agent over here. Hit create. In a few seconds, you reach the agent builder screen. Let's go ahead and collapse the left-hand sidebar. We'll keep this option selected, which is create and use a new service role. Let's leave it at that. Let's see what are the other options over here for models. Let's select 3.5 Sonnet v2. Apply. Let's go ahead and paste the instructions that we copied. We are not going to add a knowledge base or a guardrail at this moment for this agent. Let's go ahead and save it. Now, even though we are saving it, we cannot immediately start using it. There is one more step remaining before we get to do that. That is called as preparing the agent. So let's do that. Alright, so we see the agent was successfully prepared. Now let's go ahead and test it out. Let's click on show trace. So you see over here, the LLM is saying adjust cape and speaks in a gravelly voice. Justice, the purpose of life is justice, so on and so forth. See over here what exactly happened under the hood. It made a call to Claude 3.5 Sonnet v2. What was the system prompt? So over here we see aspects of what we mentioned in the agent instructions. Alright, till over here. And then we see the remaining part of the prompt which we didn't add, but which is part of the Bedrock platform itself. So let's move on to the next step. We are going to create some private data that we'll then add to our vector store so that we can effectively test whether our agent is doing RAG properly. Otherwise, it might give some answer which is already coming from the underlying data of the foundational model, and we will not be able to effectively ascertain whether the RAG pipeline is working. So how do we do that? We're going to create some fictitious data. So I'm going to Claude saying, create 1000 words about a fictional creature called the J flag. Make it sound like a Wikipedia article. And it does that. So it has come up with the scientific name for this fictional creature. It has gone ahead and created different aspects of it. What does it look like? The habitat part of it, where exactly on the earth you can find it, and all of that. So we'll give it a few seconds to go out and generate this, and then we'll download this PDF and push it into our vector store. Alright, so it's done with that. Let's download the PDF. Alright, now we'll go to Astra DB. So over here, I'm in the home page. Now I already have one particular vector collection or vector database. So I'll navigate over there. I'll be able to see one collection over here which is already there. You're just going to use that. Feel free to go ahead and create your own new vector database as well as your new collection if you don't have one already. This one that I've already created has 1024 dimensions. Why 1024? Because it's a round number in binary. It's 2 to the power of 10. So we'll go here. This is an empty collection as of now, 0 records. So we're gonna load that data over here. Let's go to that. JFlag. Now there are some controls provided by AstraDB so that we can decide how the chunks are created. I'm going to go ahead with the default values, that is 500 characters maximum in one chunk and 0 chunk overlap. Feel free to go ahead and play with this later on, but as of now this is what I'm going to do. Alright, so that is done. It's a short file, less data, so we have all the chunks created over here. You can go ahead and take a look at some of the chunks over here. Alright, so you're able to see that the content from the PDF has been ingested into our vector store collection. So with that, we'll move on to the next step. So now, since we already have the private data ingested, we'll start working on the tool which will connect to AstraDB, get this data, or basically do the retrieval of the relevant chunks from this vector store, which is, if you remember, not in the AWS ecosystem. So it is going to get that information and supply that information to our AWS Bedrock agent. How do we do that? We're going to create a simple Lambda function. The code is already over here. Let's copy that. We're going to head back into AWS, go to the search bar, select Lambda. I'm going to create a function, author from scratch. Let's call it. Select the runtime as Python 3.13. We don't need to go ahead and change any of the other options. Create a function. In a few seconds, the Lambda console will be available for us, where we can go ahead and modify the functionality for this particular Lambda. We don't need to do this right now. So this is what we have. And you see that there's a version of VS Code available over here. We're just going to go ahead and maximize that. So I'm going to replace this code with the code that copied. I'm going to save it, going to deploy it. Now there's a test option over here. But how do we exactly go ahead and test it? We need a test event. So for that, I'm going to give it a name. And before you do that, let me just show you this. So there are a bunch of templates available. This Hello World, there's a template for Kinesis, data stream, CloudWatch logs, API gateway, but there is no template available as of now for Bedrock agent. So which is why we will go ahead and create that on our own. Okay. Let's go back here. Let's take this, paste that, save it. Okay, let's comply with the requirements, save it. The test event is saved successfully. Let's go ahead and invoke it. All right, now this is expected because we have not gone ahead and configured the values for it. Okay, so let's do that. Well, let's take a look at what exactly is happening in this code. So it is reading 4 values from the environment. Now how do you go ahead and set that? Let's go ahead and minimize this. Let's go to configuration. Let's edit this timeout as well. Okay, so by default the timeout is at 3 seconds, kind of less. Let's go ahead and change that. Let's add 1 minute over here. Save that. Going back to the environment variables part, so we click over here. This is where we can add it. So over here we'll click on edit, we'll click on add environment variable, we'll go ahead and put Astra endpoint. Right, now where do we get that from? Head back into Astra, click on connection details. Over here you see the endpoint right here. Let's copy that, come back over here, add the value. Let's double check that you haven't copied any single quote, any spaces. Add another environment variable. What is the other environment variable? We need Astra token. Let's copy that, mention that here. Now where do you get that from? Let's head back into Astra DB. Let's go here, go to account settings. Here click on tokens. If you already have created a token, you can just use that. Otherwise click on generate token and then put that value over here. And in my code I've actually configured the key space to have a default fallback value of default key space and collection of pointing to my collection, which is quiz prep collection. You can obviously override this. You can mention over here collection and give it whatever name that you want to. After you are done, ensure that you save. Now we'll head back into code. Let's maximize this. We already have this test event over here. Let's go ahead and test it out. Let's maximize this. Perfect. So we see that the particular test event name is highlighted over here. We see that we got the response. So our Lambda is working properly. It has been able to connect to the Astra DB endpoint using the credentials that we provided, and it has got back relevant information chunks from Astra DB. You see that it's talking about JFlies, JFly imagery, early European naturalist, and all of that aspect which Claude went ahead and created based on our prompt. It has done that. And there are also a bunch of logger messages which are there in the code, which have also been printed. So now we have verified that the Lambda function is working properly. But there is one additional step that is still required before our Bedrock agent will be able to invoke this Lambda function. So let's take a look at that. Let's go back here. We need to go ahead and attach the tool to the agent. This last step basically has 3 different aspects. We need to first go ahead and attach the Lambda to the agent, but that's not enough. We need to also instruct the agent when and how to use the tool. So there is one part about us just telling it that, hey, you have this new functionality or this new tool. When do you call it? That is one. Then you have the open API spec, which will go into the nitty-gritties of how to call the tool. And then finally we have the Lambda permissions, which we need to configure so that our agent is able to call the Lambda function, because without that you still run into service role related issues. So let's first copy this agent instruction. Let's go back to our AWS console. I'm going to open Bedrock in a new tab. Go over here to agents. Let's figure out the agent which we had created. Let's go into edit in agent builder mode. We're going to replace our prompt with this. Let's just verify that. Okay, perfect. We have that. Let's go ahead and add an action group. Let me just get rid of that. So over here, we're going to give it a name. Now let's take a look at this prompt. We're saying that the action group's name is read from Astra. So that's the name that I'm going to give it. Define with API schemas. We'll come to that in a moment. Instead of quick create, we are going to select an existing Lambda function. This is the one that we just created. We are going to leave it with the latest version. And we are going to define the API schema. So I'm going to select this, delete it, come back over here, copy this API spec, save it. Okay, so that is done. Save it over here. Let's prepare it. Let's ask it, what is a JFly? It should fail. So the permissions are missing. How do we resolve this? Let's go back. Let's exit the testing part. Let's go to save and exit, because we'll need to copy the agent ARN over here. Okay. Now let's go back to Lambda. So here in Lambda, we'll go to configuration. We'll go to permissions. We'll go to add permissions. We'll select an AWS service. Over here, we do not have Bedrock agent listed. So we'll select other. We'll go back to our reference page. Statement ID is what we'll mention over here. The principal, Bedrock, Amazon AWS.com. Let's go ahead and copy that. What is the source ARN? Let's go over here. We have this agent card. Let's go ahead and select the agent ARN. Let's mention that, and which is the function that we want to allow it to go ahead and call. Okay, or the permission. So Lambda invoke function. Now with this, hit save. Now this should work. Let's go back over here. Let's end this session. Let's prepare it. Let's collapse the left hand sidebar. And let's maximize this. Let's run this. Let's take a look at the traces over here. So it is using 3.5 Sonnet v2. It has made a call to Lambda. Okay, so it is saying let me search for information about JFly in the AI knowledge base to provide accurate information. There's a call to Lambda being made. You see that read from Astra, action group, the API path, the search term. So even though we asked what is a JFly, it has figured out that the search term should be just JFly. Made that call. There's an observation, okay, all the response that you got from the Lambda invocation. So this is basically the chunks which were retrieved from Astra DB. So all of that is here. That was step 1. Step 2, we can't just return this as is to the user, because that would be odd. We got to take this content and then frame an appropriate answer to the user's original question, which is what is a JFly? So trace to, now we're saying that, hey, you got all of this content, generate a proper response. Okay, so now it is saying based on the search results, I can provide a comprehensive answer about what a JFly is, and here is that. So what we have achieved now is a Bedrock agent connected to an Astra DB vector search through Lambda. I hope this was useful. Try this out on your own. If there are any issues, reach out to me on LinkedIn or add some note on the GitHub page. Thank you.